5.5 is polynomial equations, so we're going to look at factoring these and then using those factors to solve them. So we've got some new ways to factor today. First thing is, whenever you have a greatest common factor, you always want to factor that out first if that's possible. We have a reminder of the difference of squares when these are both perfect squares, and this is subtraction in the middle. Now we have sum and difference of cubes. So cubes is when you can have that number multiplied together 3 times by itself. Like a perfect square would be 25, because 5 times 5 is 25. A perfect cube would be 8, because 2 times 2 times 2 is 8 on there. So these are sometimes a little bit harder to recognize right off the bat, but you'll get better at it. So these are the formulas that we use for those. So in our first example, when I look at this, I'm always going to first check and see if there's a greatest common factor that can come out first, which in this case there is. So these are both divisible by 3, and they both have at least an x squared. So I'm factoring out 3x squared. Then I have 8x cubed left and a y cubed here. Okay, now these, when I look at what's left in here, this matches this pattern. So this is a sum of 2 cubes inside of here. So what I'm going to do when I have that is I'm going to identify what the a and the b would be, and then that'll help me kind of plug the stuff into this formula. So in this case, the a is the cubed root of this stuff. So in other words, what thing times itself 3 times would give me this? And that would be 2x, because if I multiply together 3 2x's, that's going to give me 8x cubed. Then the b term is going to be y, because if I multiply together 3 y's, that gives me y cubed. So now this part right here that's inside the parentheses, I'm going to substitute into this sum of cubes formula, and I still have this in the front. So I have a 3x squared in the front. So then I have a plus b, so 2x plus y. Then I have a squared, so 2x squared is 4x squared. Minus a times b, so 2xy, and then plus b squared would be y squared. So this, even though it looks way more complicated, is actually the factored form of this polynomial. Alright, factoring by grouping. So with grouping, what we're going to do is look at the first and last terms. We're going to group them together here. And I'm putting addition in between there. Now on each of these I'm going to take out the greatest common factor. So in here, between an x cubed and a 5x squared, I can factor out an x squared, which leaves me with an x plus 5. Now in here, when I look at these, I could factor out a negative 2, so that's going to leave me with x plus 5 here. This is the thing about grouping, is these things in the parentheses always have to match up. So now the parts in the front come together, x squared minus 2, and then these factor together into one factor here. So this is the factored form of this polynomial. Alright, example 3. So again here we have actually a difference of cubes, so I'm going to be using this formula here for this. So I need to figure out what would multiply together 3 times to equal this. So if you don't recognize that a number is a perfect cube, the way you can check that is the cubed root, or the opposite of that would be taking it to the 1/3 power. So if I do 64 and raise it to the 1/3 power on my calculator, that gives me 4, which means 4 times 4 times 4, 3/4 is equal to 64, or 4 cubed. So the cubed root of 64 is going to be 4, so my a value is going to be 4. And then how do I break down x to the 6th so that it's 3 of the same thing being multiplied together? So that would be x squared, because if I have 3x squareds multiplied together, that gives me x to the 6th. So same thing with the y, I would need 3y squareds. Sorry, this is what the b is going to be. B is equal to y squared. So now let's plug it into this difference of squares formula. So a minus b, so I have 4x squared minus y squared. Then I would have a squared plus ab plus b squared. So this squared is going to be 16x to the fourth. Then I have a times b. So that's going to be 4x squared y squared, and then plus b squared. So y squared squared is y to the fourth. All right, example 4. So this super long, funky looking thing, we can actually group stuff together on here. So when I look at this, these all have y's and these all have z's. So I'm going to group together my y's and I'm going to group together my z's. Now in here, these all have a y cubed. So I'm going to factor a y cubed out of each of them. And over here, we have a z cubed in each of those. So this becomes, and as you can see, these match up to be the same again, which is what we want. So these two pieces are going to come together in a factor, y cubed plus z cubed. And then this stuff that was in the parentheses is my other factor. Now I can actually keep going with this because this is now a sum of cubes, and this can be factored. So in my sum of cubes formula, my a value is going to be y, and my b value is going to be z. So I'm going to substitute those in here. Y plus z, y squared minus yz plus z squared. So that is the factored form of this part. Now this can actually be factored too. So here I have a trinomial. Numbers that multiply to equal positive 2 and add to negative 3 would be negative 2 and negative 1. So this whole big long thing would be the factored form there. Okay. Now this one, if yours has that, we're going to change it. X to the fourth minus 29x squared plus 100. Alright, so now we're actually solving. So we're going to factor them and then set our factors equal to 0 and solve. So as you can see, this is a fourth power and this is a squared power. So I can actually rewrite this so that it looks like a quadratic like we're used to. So I'm going to use the letter u here, and I'm going to say u is equal to x squared. So if I rewrite this then, this is going to be like an x squared squared is an x to the fourth. And now I'm going to replace these x squareds with u's here, just so that I don't have quite as much going on in this problem to look at first. Just kind of cleans it up a little bit. Now I'm going to factor this, because this is factorable. So two numbers that when you multiply them you get 100, and when you add them you get negative 29. That's going to be negative 25 and negative 4. So now I can set these factors equal to 0. Which means u would equal 25 and u would equal 4. But what u really was, now I'm going to go back to the beginning here, u was really just a substitution for x squared. So this is really x squared equals 25 and x squared equals 4. And then I would take the square root of both sides of that, so I would get x equals positive and negative 5 and x equals positive and negative 2. Alright, one more. So I have on here, this is a sum of cubes. So I'm going to use that sum of cubes formula. I'm going to say my a value is going to be x. My b value, the cubed root of 27, is 3, because it takes 3 3's multiplied together to give you 27. So this would become x plus 3. And then x squared minus 3x plus 9 equals 0. So now we'll set both of those factors equal to 0. Okay, Okay, now this one, you'd subtract 3 from both sides and get x equals -3. Here, this is not factorable, so we need to use the quadratic formula. So b squared minus 4ac would give me this, which equals -27. So into the rest of my quadratic formula, I would have -b, so -27 all over 2. Then from there, this can be broken up, so I'm going to have a I, because it's got the negative underneath, the square root of 9, and the square root of 3, which becomes 3i root 3 over 2. So we have this and this as my solutions on there. Alright, so you have 2 of them to try. Just factoring, these are not quite as difficult as some of them we did above. And lastly, your joke. Why did the bird go to the hospital? Because it needed treatment. Okay, I hope you have a great rest of your day, and make sure you're kind to someone today.